Hello, everyone, and welcome to yet another episode of the Boost Your Biology podcast. Today, I'm joined in with a very special guest. He is what I would consider the leading researcher on a specific vitamin that you've probably heard me talk about quite a lot, and that is vitamin B1, also known as thiamine. And some of you will also be familiar with some of my personal experiments with high-dose vitamin B1, which we'll probably get stuck into throughout this podcast. But without any further ado, welcome to the show, Elliot.
Thanks for having me on.
Awesome. So maybe did you want to give my listeners a bit of a background into, I guess, your journey and how you got so fascinated with vitamin B1?
Okay. So I'm a nutritionist. I'm based in the UK. I have a particular interest. I have some training in what's referred to as functional medicine. Again, I'm not a medical doctor, but yeah, when we're looking at kind of functional medicine, it's primarily nutritional based. It's trying to identify the root causes of chronic illness, right? So in our modern world, as you know, we're bombarded with chemicals and processed diets and all of this other kind of stuff. And chronic disease is very much skyrocketing. It's on the up in much of the Western world. So I've always had a bit of an interest in health, but I originally became interested in nutrition specifically and how that can be used to improve chronic disease. And so I studied, I got my qualifications, I went through kind of some of the functional medicine training programs as well. And I consult with people primarily from every continent, actually. So I don't just work with people in the UK, I work with people from all around the world these days. And in the context of vitamin B1, it's when we go through nutrition training, we learn the basic kind of biochemistry behind the B vitamins and how they function in the human body and things. But in terms of the clinical application of vitamins or orthomolecular medicine, right? So using specific nutrients in high doses or in controlled doses to improve different health conditions. If you know anything about nutrition, you know anything about kind of alternative medicine, then you will have been familiar with many kind of advocates of methylfolate or vitamin B12 therapy or vitamin B6 or niacin therapy. There's lots of information online and around in the alternative medicine communities about using different vitamins in the context of chronic health conditions. What I will say is that there is very, very, very little information on how thiamine or vitamin B1 can be used to treat or improve diseases, right? And so I came across a book a couple of years ago. It was by probably the leading physician using vitamin B1 in clinical practice. His name was Dr. Derek Lonsdale. And he co-authored a book with a PhD. Her name is Chandler Mars, who runs a website called Hormones Matter. Anyway, they wrote this book and it's called Thiamine Deficiency Disease, Dysautonomia and High Calorie Malnutrition. And after reading that book, my lens or my scope of view was widened significantly, and I developed a pretty significant interest, or what you might call a fascination, with this one B vitamin. And so, I decided to try to learn as much about it as possible and started using it in quite high doses in clinical practice with real people. And I was nothing short of amazed by some of the results that I would have. And there's, when you work with people who are chronically sick, then you go through lots of different protocols and you try lots of different things. And when they don't work, then you're kind of left in the lurch. You don't know which way to turn. And for some of those very difficult clients who had tried many other different approaches, using vitamin B1, what I found is that, again, it can provide in some people nothing short of a miracle in terms of addressing their symptoms. So that ever since that point, I've just really been very interested in learning about B1, applying it in clinical practice, and in trying to educate others as much as possible.
Yeah, I really like that. So I want to sort of delve into more about the energizing aspect of vitamin B1, because I came across, I think it was one paper where it was a study in fibromyalgia patients. And I remember just seeing a little snapshot of the conclusion section sort of saying a complete regression of fatigue in like 90% of patients. So let's sort of, for my listeners, you want to sort of explain why vitamin B1 is so critical for energy production?
Yeah, okay. So essentially, if we look at how cells take food and convert that into energy, it involves lots of different steps. So when you digest food, you have to break it down into much smaller constituent molecules. And those smaller molecules, whether it be glucose, fatty acids, amino acids, you're going to transport those and take those into the cells. And each different cell needs energy to function, to do what it needs to do. And so essentially, when you have these very small molecules, what you have to do further to derive energy from those, or to derive the energy that's contained within those molecules, you need to send them through several different steps. And this is referred to as energy metabolism. So it differs slightly between different types of molecules. For instance, glucose is going to go down certain routes and fats are going to be broken down in other certain ways. But ultimately, they end up in the same place in a section called a part of the cell called the mitochondria. And the mitochondria, that is where you're funneling kind of electrons through several different stages, and you are making ATP, which is biological energy. So each of those different stages, when we're taking energy from food, most people know about macronutrients. They know about proteins, fats, carbohydrates, and all of these contain some energy that we can kind of make use of. But what we need to understand, this is the most critical point, is that to derive energy from those macronutrients, we need micronutrients. And this means the vitamins and the minerals. And so each consecutive stage of energy metabolism requires different B vitamins. And so that includes B1, thiamine, as we're talking about today. It also includes vitamin B3, B2, folate and B12 are involved kind of tangentially. And so if we look at why B1 is so central to energy metabolism, well, B1 is necessary for the initial phases of the breakdown of carbohydrates. So it's also involved in how we are deriving energy from protein to a lesser extent, but also to fats. But if we're looking at carbohydrates specifically, it is crucial. It's a cofactor for an enzyme called pyruvate dehydrogenase. And so pyruvate dehydrogenase is involved in one of the initial phases of breaking down glucose into pyruvate and then pyruvate into acetyl coenzyme A to enter into something called the Krebs cycle. But without going into those details, what we need to understand is that carbohydrate metabolism needs B1. Simple. Now, in our modern world, why can thiamine, or how can thiamine be so helpful for people? Well, if we look at how modern diets have changed compared to just a couple of hundred years ago, or even if you want to go thousands of years ago, if you're looking at kind of ancestral or Paleolithic times, the availability of dietary carbohydrates would be limited to season. And likewise, it would be unprocessed. Whereas if we go to modern day diets, what we see is that there is an overabundance of processed carbohydrates and sugars. Now, when you process a food, or when you kind of eat refined sugar in some way, that has had all of the goodness, all of the micronutrients taken out of it. And remember that I said you need micronutrients to burn macronutrients. And so if you're eating a high refined sugar, high refined carbohydrate diet for a long period of time, what ends up happening is the amount of energy coming into the cell surpasses the amount of micronutrients that you have to burn that energy. And so what you end up with is a problem where the overconsumption of carbohydrates, refined sugars, actually ends up depleting us of the nutrients we need to burn those things for energy. And then we come to thiamine. So thiamine is the biggest, thiamine is the biggest kind of target of refined sugar. We need thiamine to burn sugar. And if we don't have enough thiamine, we can't burn sugar. Now, if we continue eating sugar, then what ends up happening is we end up with a cellular energy deficit. And here is where you might see a benefit in something like fibromyalgia. Fibromyalgia is characterized by lots of different changes, but there's changes in the brain, but there's also changes with energy production in the muscles. Same applies to things like chronic fatigue syndrome. If we do not have enough micronutrients, in this context, thiamine, to burn that energy, we can't burn it, okay? And we might end up putting it on as weight. We might end up weeing it out this is what kind of happens in diabetes. And essentially, cellular energy metabolism slows right down. Now, not only is refined sugar, refined carbohydrate going to be a really important kind of influence on determining how much thiamine we need, there's also lots of other things in our modern world which tend to deplete our body of thiamine or prevent us from absorbing that. There's many beverages, including coffee and tea. If someone drinks 5 cups of coffee every day, then what that's going to be doing, the tannins contained, these phytochemicals contained within certain beverages, inhibit the absorption of this nutrient in the gut. Likewise, there's certain antibiotics. One is known as metronidazole, or otherwise known as Flagyl. Flagyl is what is called a thiamine analog. This means that it can prevent the absorption of thiamine, but it can also influence how we process thiamine in cells. And so this is one of the other things that can lead to a deficiency. If someone is drinking lots of alcohol, alcohol is going to be producing the classical form of thiamine deficiency, which is called beriberi or Wernicke's encephalopathy. If an alcoholic is admitted into the emergency room or the accident and emergency department in a hospital, they will generally be given thiamine via IV because alcohol tends to deplete that. There's numerous different factors in our modern world which can deplete us of thiamine. But primarily, it's going to be this long-term consumption of refined foods, refined carbohydrates, which can very much deplete our stores. And this not only applies to thiamine, but since thiamine is so important to break down carbohydrates for energy, that's one of the things that is very much it's affected the most, I believe.
Yeah, you did a fantastic job at sort of breaking down just how important vitamin B1 is when it comes to supporting overall energy metabolism and ATP production. But I sort of want to segment into, and this is coming from both personal experience and people that have recommended vitamin B1 too, is that when you take vitamin B1 on its own versus in a B complex, I personally have noticed a clear-cut day and night difference. So I want to explore more about why is it that vitamin B1 on its own subjectively may feel completely different to like a B complex.
Okay, so I just want to ask a question. When you're taking B1 on its own, is that in a different dose to a B complex? Is that a higher dose that you're taking?
I would say it's almost on par, between 50 to 100 milligrams of thiamine HCl.
Okay, look, that's a very good question. That's a very good question. And I'm not entirely sure whether the answer to that has been fleshed out. What I would say is that essentially, we have to look at the B vitamins as being in a complex. So they all work together. They work in tandem. So for instance, you think of how cells make energy is essentially, it's like lots of different cogs, multiple cogs. And that when you drive the one cog, what can happen is that is going to affect the other cogs, right? Lots of different cycles upon cycles within cycles. And so when you give one individual nutrient, what you're doing is you think these nutrients are cofactors for enzymes, okay? Enzymes are like the cogs. And so when you give one nutrient, what you're doing is you're increasing the activity of those processes which need that nutrient specifically. So I'll give you an example. When you take B1, you are going to be specifically increasing the activity of the enzymes, 1 pyruvate dehydrogenase, 2 alpha-ketoglutarate dehydrogenase, and 3 branched-chain keto acid dehydrogenase. There's going to be a couple of others, transketolase involved as well. But again, we don't need to get too much into the biochemistry. But basically, those are like lots of different cogs. Okay?
Yeah.
However, there are also many other enzymes involved in energy metabolism which do not need B1. They don't require B1. Okay, so when you give one nutrient in particular, what you're doing is you're driving the one process, and you can increase the need for the other process. Alternatively, if the other cycles or the other cogs are running efficiently, but it's just the B1 dependent cogs which are slowing behind, then taking B1, how to say this? Right, when you give one nutrient, what you're either doing is you're increasing the need for the other nutrients, or you're bringing those processes back into some kind of equilibrium. Okay, so for some people, right, for instance, if they are perfectly fine on B2, B6, B12, folate, biotin, and yet they're just low in B1, then taking B1 by itself might allow the cells to reach some kind of some semblance of normality, right? Because if all of the B1 dependent processes were lagging behind, when you take extra B1, that's going to kind of come up to speed with the rest of the processes. Right. Okay. However, when you take a complex, any B vitamin is going to increase the activity of the enzymes that it's used in. So you imagine taking a B complex. If your thiamine dependent processes are slightly lagging behind, but then all of the other processes are not, which require the other Bs, when you take a B complex, you're increasing everything. So that's not necessary. It's just bringing it to a higher level. It's not necessarily addressing the initial deficit and bringing the B1 dependent processes back into, kind of on the same level as the others, if that makes sense. That's highly theoretical. That is the only possible thing that I can think to explain why some people respond better to taking B1 by its own rather than in a complex. I think that what's happening when they're taking B1 by its own is it's helping to bring the other things back at kind of in line with the rest of the other processes inside the cell. But I'm not sure. That's highly theoretical. Take it for what it's worth.
Yeah. Okay, well, it makes sense to me. I mean, I understand that when you're talking about the different systems and how maybe sort of leveling up one, but then the other cogs are sort of lagging behind. But Elliot, I want to sort of discuss more about how B1 affects cognition and the brain, because I talk about nootropics and enhancing brain function quite a lot. I explore many of the, CDP, choline, other nootropics to increase acetylcholine, dopamine, things like that. So I want to explore vitamin B1 in the context of brain health, and specifically how vitamin B1 can act, I guess, as like a strong neuroprotective agent.
Okay, yeah. So that's a loaded question, right? And there's a lot to this. I don't know how deep you want to go with this, but if I go into too much detail, just cut me off. Okay.
Yeah.
Right. Okay. So to understand, because this is something that we haven't spoken about. We've spoken about kind of refined carbohydrates, how they can make the body kind of low in this B vitamin, but we haven't actually spoke about what happens when someone does become low. Okay. So we have to look at a little bit of history to understand this. So essentially B1 is one of the B complex vitamins. It was the first, if I remember correctly, it was the first identified B vitamin. And the reason for this, or if we look historically, we look at what kind of precipitated research into this kind of area. It was in Japan. So if we go back to Japan, I think it was in the early kind of 20th century, maybe a little bit earlier. What happened was, in Japan, they consume a lot of rice, and they have for a very long time. The kind of rice that they were eating for a very long time was brown rice. Okay. That's rice which is not being refined. It's not had the bran taken out of it. Right. And so that was not much of a problem. They can kind of subsist on that with a little bit of meat and whatever. But what started happening was that there's a bit of a class divide in Japan. And what you had was you had the higher classes could then afford to start milling the rice. And that milling process is the difference between brown rice and white rice. Fundamentally, what milling is doing, or what the refining process is doing, is getting rid of the bran. Okay. So that bran, the outer kind of husk, that outer brown hard shell, that was discarded. And so what you ended up seeing was as status symbols for the higher classes to kind of exert their, or to identify themselves as higher class. They could afford to have their rice milled. What happened was these higher classes started consuming lots of white rice. Okay. Now, unfortunately, back then, it wasn't known that the outer bran of the rice was the thing which contained all of the B vitamins, particularly thiamine. So what you ended up seeing in Japan was people who consumed lots of this white rice ended up developing a wide variety of different symptomatic presentations. So this was eventually identified as what is referred to as beriberi. This is the classical thiamine deficiency disease. You had people developing all kinds of neurological issues. The way that this would typically present, it could be in one of three systems. And this is in the brain and the central nervous system, the peripheral nervous system. So a certain subsection of people would develop severe neurological issues. They might develop dizziness, cognition, memory loss. They might develop kind of tingling, numbness on their hands. Some of them lost the ability to walk. All of these are the kind of neurological problems, which look similar to something like progressive multiple sclerosis or Parkinson's disease or Alzheimer's dementia. You also had another group of people who would develop cardiovascular issues. They might develop an enlarged heart. They might develop kind of atrial fibrillation, cardiac failure, edema, all of this other kind of issues. And then you would also have another group of people who would develop symptoms primarily in the gut, in the gastrointestinal tract. So they would develop severe constipation, inability to digest food, inability to kind of process or propel through food throughout the GI tract, severe bloating, vomiting, nausea, diarrhea, all of this other kind of stuff. And then you'd have the unlucky bunch who would present in all three, right? So basically, thiamine, not only is it really, really, really important for how cells are making energy, and that's every cell in the human body. However, when we're looking at the other functions of thiamine, it's very, very, very important for the central nervous system and the peripheral nervous system. So aside from its role in generating ATP, it's necessary for the maintenance of the myelin sheath in the brain. It's necessary for the production of a neurotransmitter, like you said, acetylcholine. And so when someone is low in B1, what ends up happening is that they can no longer generate acetylcholine. They can no longer maintain a healthy myelin sheath. And so you develop symptoms which are similar to multiple sclerosis. You develop symptoms which are similar to some kind of acetylcholine deficit. Essentially, acetylcholine is the neurotransmitter. It's the neurochemical which is responsible for it's the primary one in what's called the vagus nerve. And the vagus nerve is the primary nerve in kind of involved in modulating the parasympathetic nervous system. And so this is otherwise known as your rest and digest nervous system. And so when you lack acetylcholine, you lose this balance between parasympathetic and sympathetic. And so there's lots of issues that stem from that. And that can affect the GI tract, that can affect the heart, that can affect the other kind of the rest of the nervous system. If we look at basically, right, if we're looking at the brain and we see how the brain is making energy, there are certain areas of the brain which require more energy than others. They have a more rapid rate of metabolism. If we're looking at which areas of the brain that is, that's primarily the lower brain areas, the brain stem and kind of the areas surrounding that. And those are the areas which are responsible for governing what is referred to as the autonomic nervous system, of which the parasympathetic and the sympathetic branches kind of the category they fall under. And so when someone is low in B1, when they're low in thiamine, then those areas of the brain, those lower areas of the brain, are the first to become dysfunctional. Okay, when cells don't have enough energy, like we said, cells don't have enough energy, they can't work. And so therefore, what you do is you lose control of the entire autonomic nervous system. And so you'd have these people with all of these symptoms which would fall under the category of dysautonomia, and lots of different problems kind of there. And so B1, if you want to remember it, B1 central to the nervous system, very important. But if we're talking specifically about cognition as well, with brain function, again, I'm not a neuroscientist, but the basics of it is that to be able to maintain healthy brain function, not only do you need energy, we know thiamine is central to that. Not only do you need healthy myelin sheath to conduct nerve signals from one another, thiamine is essential to that. You need acetylcholine, which is the neurotransmitter. Thiamine is essential for that. But what you also need to be able to do is clear out waste products. You need to have a balance between different, what are referred to as excitatory and inhibitory neurotransmitters. So we're looking at, you listeners probably know all about GABA and glutamate. In simple terms, glutamate calms neurons down. Glutamate excites neurons. So glutamate is excitatory. It stimulates neurons. GABA is inhibitory. Now, generally in our modern world, or people who have any kind of cognition issues or neuropsychiatric issues, the research seems to indicate that they have a bit of an issue balancing GABA and glutamate, with a tendency towards higher levels of glutamate and less levels of GABA. Now, in that kind of situation, when you have excessive firing of neurons, what this does is it causes oxidative stress. Now, it turns out that to clear glutamate, you see, to balance glutamate and GABA, you need to be able to get rid of excess glutamate. And thiamine is really, really, really important for that. In fact, it's essential. And one of the first signs of thiamine deficiency is a lack of, or this predisposition towards higher levels of glutamate. So people can become anxious. They can have kind of schizophrenic tendencies. They can develop insomnia. They might develop kind of depressed mood. There's lots of different areas with relation to cognition, thinking capacity, memory. All of these other things can be related to excess levels of glutamate, not enough GABA, but also the oxidative stress which comes from a situation like that. Now, what we haven't spoken about, and this is not just in relation to the brain, but it does apply in the brain as well, is that thiamine not only, again, we spoke about those enzymes in energy metabolism for making ATP. Thiamine is also a critical cofactor for an enzyme called transketolase. Now, transketolase, simple way to think of it, is it helps us to maintain our antioxidant status. What it's doing is it's producing a molecule, a chemical called NADPH, which helps us to regenerate glutathione. Now, if your listeners know anything about glutathione, basically it's the main cellular antioxidant, helps us protect against all the damage in our modern world, okay? Outside of the context of our modern world, we need glutathione, but especially these days when we come into contact with chemicals, exhaust fumes, all of these things, they tank our glutathione status. So we need to continually regenerate that. And we use a thiamine-dependent enzyme, transketolase, to do that. And so when you lose thiamine, when you do not have enough, you have this tendency towards developing severe oxidative stress. And this doesn't just affect the brain, but the brain is particularly susceptible because the neurons are lined with highly unsaturated fatty acids, which are very susceptible to damage. And when you get damage in those areas, you get memory loss, you get cognition issues, etc. And then so you're using, thiamine can be used specifically to increase the production of acetylcholine. And acetylcholine is basically correlated with cognition, right? Aside from kind of excess, which is related to seizures, but generally improving acetylcholine is essential. That's one of the mechanisms behind something like alpha GPC or CDP choline, these other nootropics. That's one of the mechanisms of action. But there's also something else that we haven't kind of discussed. And this is really what's very fascinating, is that when we look at the effects of oxidative stress on the brain, when we look at how this affects energy metabolism, what we need to understand is that when you have any kind of stressor, when you have what is referred to as oxidative stress, you have lots of free radicals, that it's damaging the neurons, it's damaging the cells, but it also has a direct effect on the way that cells make energy. So there's certain enzymes in those pathways which are susceptible to the effects of free radicals. Basically, what this means is that free radicals or reactive oxygen species, what that does is it inhibits the enzymes involved in energy metabolism. And when you get that inhibition, you get a lack of ATP. And then that is like a cycle which perpetuates kind of oxidative stress and neuroinflammation and cognition issues. So there's some excellent research showing that someone doesn't necessarily need to be thiamine deficient to benefit from the effects of thiamine.
Yep.
I mean, okay, basically, without going into too much detail, because it takes a long time to explain this, but basically, right, there's research showing that in rats, you have traumatic brain injury. Okay. Traumatic brain injury is a major stressor for the brain. It causes inflammation. It causes oxidative stress. It can cause permanent neural damage. And it basically puts the brain on fire. And when you have that, you have inhibition of ATP synthesis. So you get lack of brain energy and lots of problems associated with that. Well, there's research showing that the main enzyme affected by some kind of oxidative stress or traumatic brain injury is alpha-ketoglutarate dehydrogenase. This is a thiamine-dependent enzyme. Now, there's a research study showing that if you compare two rats, you give them both head trauma, so traumatic brain injury, you give one group of rats high-dose thiamine a couple of hours before, and the other group of rats are the control group. What they showed was that high-dose thiamine before traumatic brain injury was enough to overcome the inhibition of the enzymes involved in energy metabolism, completely protected the brain from all of the oxidative stress and everything, whereas the control group were practically brain dead. So it seems as though using molecules, using vitamins in high doses may not only be related to addressing a deficiency or addressing an insufficiency, but may actually come in handy in protecting the body from the effects of oxidative stress in some unknown way. There's lots of research on this, but again, it's a wide topic.
Yeah, I mean, I want to quickly share my experience with high dose vitamin B1. So I probably started using it about maybe 2 years ago. I started at very small doses, like 25 milligrams. This is just of the regular thiamine HCl. 25 milligrams, built my way up all the way to around about 400 milligrams per day. And just from like my initial response in terms of like the mental clarity and just the ability to memorize content, it helped me with studying. My verbal fluency improved. I just felt generally like a lot more switched on. And then I sort of delved into more of the research and, I found out that it improves acetylcholine. But then I also found one study demonstrating its effects on helping to clear out lactate or helping with that lactic acid buildup. And I'm someone who trains very intensely, like 5 days a week, high intensity, like weight training. So I'm generating a lot of lactic acid. And I know a lot of my listeners will also be training very hard. A lot of athletes listening in will be training super hard, building up a lot of lactate, soreness, DOMS, things like that. So do you want to sort of talk about how vitamin B1 can support the body's ability to detoxify lactic acid?
Yeah, okay. So we spoke briefly about how thiamine, the enzymes which use thiamine, one of those is called PDH. And that is essentially, that's at the initial phase of glucose metabolism. So what you need to know is that when you consume glucose, what's happening is when your cells are burning glucose, you're using that for energy, you're running it through an initial process called glycolysis, and then that is making two molecules of pyruvate. Now, pyruvate, breakdown product of glucose, very simple. So pyruvate can go one of two routes. It can go towards what is called oxidative energy metabolism, so using oxygen in the mitochondria to generate lots of ATP. That requires B1, okay? Alternatively, it can go down an opposite anaerobic pathway, which is to generate lactic acid. Now, the generation of lactic acid is the amount of ATP or energy that you're going to derive from that is significantly lower. And you actually end up in a bit of an ATP deficit or energy deficit by doing that. But that is inevitable when the cells do not have sufficient levels of oxygen. Okay, so if you've got oxygen and you've got all the nutrients to make energy, then you will produce very little lactic acid. Alternatively, if you're in an oxygen deficit, for instance, if you're doing high intensity training, you're going to be kind of the amount of oxygen that you have is going to be limiting. It will be a rate limiting factor on how much ATP you can make. And therefore, that's one of the reasons for what is referred to as a stitch or a cramp. Essentially, your level of ATP consumption or activity is outweighing the amount of oxygen that you can get to the cells at any one given time. You're generating a lot of lactic acid. Okay. So when someone is low in B1, let's say, I don't know much about your community, but let's say bodybuilders, for instance. Bodybuilders are a classic example of people who are running a B1 deficit because oftentimes they have this tendency to consume so many carbohydrates. Some of these bodybuilders, they live off white rice and chicken. And so what they're doing is they're consuming hundreds of grams of carbohydrates, but their thiamine levels are not matching the amount of carbs that they need to actually burn. And so what happens is in these kinds of individuals is that they might have this tendency, as I said, when you don't have enough B1, you divert pyruvate or the glucose breakdown product into lactic acid. And so what thiamine can do, and this is even in the context of someone who's not in a deficient state, giving a nutrient, in this case, thiamine, when a nutrient has an affinity for an enzyme, what you can do is by giving high doses of that nutrient, you can stimulate that enzyme further. And this is the kind of rationale behind people with genetic disorders. They have genetic disorders, for instance, what's referred to as a pyruvate dehydrogenase deficiency. This is a genetic condition where the amount of that enzyme that they make is, say, 30% of what a normal person would make. And so this person is always going to have, genetically, this tendency toward making less of this enzyme. However, what the researchers have found is that by giving very high doses of a nutrient, you can bypass the genetic condition in many cases. So what you're doing is you're almost giving the information to the cells. You're telling them that by giving lots of this B vitamin, thiamine, by giving lots of this, you get the cells to make more of the enzyme. It's like bypassing the genetic issue. You get them to make more. And this also applies to someone who has this tendency toward getting lots of lactic acid. The research shows that by giving high dose B1, what you can do is you can stimulate more of that pyruvate dehydrogenase. And actually what you're going to be doing is routing the kind of energy intermediates away from producing lactic acid and towards making more ATP. And so this is one of the reasons why thiamine in high doses has shown good promise in terms of increasing athletic performance, decreasing lactic acidosis. If you look at lactic acidosis from a pathological standpoint, not from an athletic standpoint, that's one of the key signs of a severe thiamine deficiency. Because you're generating all of this lactic acid, you actually end up with acidosis. And thiamine is going to clear that immediately if you get it in IV very quickly. In the context of athletics, it also applies, but on a smaller level. Now, that's not to say that you can get rid of all lactic acid, because lactic acid plays a role and it is functional. However, by giving high dose B1, you can very much help the cells to utilize as much energy as they can. And it's also important to know that thiamine can also help oxygen transport around the body as well. So it helps cells actually absorb oxygen. It helps blood flow. It helps a variety of these other things, which are going to be helpful in a situation where someone has a tendency to making too much lactic acid. Does that make sense?
Oh, definitely, yeah. I'm loving this so much. All right, so what I want to do is transition over into, I want to talk about MTHFR, because I know a lot of people, they're talking, I've got this MTHFR polymorphism, but I want to talk about the new MTHFR, which could potentially be, is it TPP polymorph, an inability for somebody to convert the inactive form of thiamine into the active form. So let's talk more about why that is also a major issue.
Okay. So we spoke a little bit just now. I was saying about certain genetic, predispositions. Essentially, your genes are, let's say, a blueprint. They're a template, and they're not necessarily, it's not set in stone. So you said about MTHFR. I consult with I've got MTHFR. My methylation is fine. I consult with a lot of people with MTHFR, and they have no issues with something like methylation. So it's important to note, first of all, that just because someone has some genetics does not mean that determines how their cells function, right? Now, what we haven't spoken about is when you get thiamine from food, right? So you break down food, in the GI tract, you're breaking down the proteins, etc. You're liberating vitamins, you're absorbing those in the various points throughout the kind of small intestine. You're transporting those vitamins into the cells. And the transport of those vitamins, it requires certain like carrier molecules, carrier proteins. Oftentimes it's not just floating around in the blood, some of it is. But oftentimes what happens with the B vitamins, and this applies to most of them, is that you need to activate them before they can be used. So the amount that you find, say in a supplement, the type that you find in a supplement or the type that you find in food, many times it's not in a form that your cells recognize, or they recognize it, but they can't actually utilize it. Oftentimes it needs to be phosphorylated. It needs to have a phosphate group added to it. It needs to be modified in some way to participate in all of your biochemical reactions. So there are some people who seem to have a genetic issue or a predetermined kind of tendency to having a problem, not only with absorbing B1 or transporting it, but once B1 is inside the cells, it's activating it to its active form. And there's an enzyme called pyrophosphate kinase, which is responsible for activating B1. And there are polymorphisms in this gene, which essentially slow down the production, or they might mean that someone is less able or is going to be making maybe 50% of what they ordinarily should do. Now, this doesn't necessarily mean that someone will be thiamine deficient, but what it seems to be correlated with is that someone may be more likely to be susceptible to the things which are going to induce a deficiency. For instance, these are the kinds of people who, if they go on, a binge at university, drink loads of alcohol and loads of carbohydrates, they may end up crashing significantly. Alternatively, they might be the kind of people who have a severe reaction to flagyl or metronidazole and end up with chronic fatigue syndrome or fibromyalgia. They may, these are going to be the kind of people who are always, say, closer to the edge of having a health crash. Because that's what you usually see with a B1 deficiency, is that essentially when it happens, it usually happens all at once. It doesn't, in some cases it's progressive, but usually, someone's body can go a long time dealing with lots of stressors and be running at maybe 20% capacity, not present with any symptoms. And then there's some stressor which tips them over the edge. It can be antibiotics, death of a loved one, an infection, and anything which raises that metabolic requirement, they can't match it. And so, boom, you get this kind of manifestation of all these symptoms. These are the kinds of people I tend to think who have this disposition towards less of an activation of B1. And so for some people who have it very severely, to maintain good levels of health for a long period of time, these are going to be the kinds of people who probably need to supplement long term, or who find that when they stop supplementing, that they regress in their health. And unfortunately, I don't know what to do for those people. They to maintain kind of a state of functionality, they require B1 supplements, and that helps them kind of get by.
Yeah, so I guess I sort of want to transition over into the different types of B1 supplements, and specifically I really want to talk about the relatively newer form, TTFD, which is not, I'm confident that 95% of my listeners will have never heard of it before. And I remember actually posting one study on Reddit, in a Reddit sub-nootropics Reddit, about how TTFD can improve dopaminergic neurotransmission, which immediately caught my attention because I'm all about optimizing dopamine, things like that. So yeah, let's break it down. Let's talk about focusing mostly on TTFD.
Okay, yeah. So looking at different forms of B1, essentially this goes back to Japan. So we spoke about how in Japan, they'd identified that the people who ate white rice got really sick. And what they had to do, they did a bunch of research on this, and they discovered that it was B1 thiamine specifically, which was responsible for these symptoms. When they supplemented with B1, a lot of people got better. And so that's how they identified it. They shared it with the international science community. And what they found out was essentially what, that spurred on the study of vitamins across the world. However, what they did was some people would respond very well to the ordinary B1, but there were many people who didn't, okay? And over the next kind of couple of decades, they pummeled lots of research or lots of resources into studying the best forms of thiamine. Like, what was the best form? How could they come up with a form that could address a deficiency in the best way possible? So they studied multiple forms. They spent, a long time. It was primarily a pharmaceutical company called Takeda Research who had done a lot of this research. And so what they identified was that there were different forms. If you had thiamine in different types of food, then that might be different to the thiamine that they could synthesize. An example was one type of thiamine called allethiamine. Okay, allethiamine, they named it allethiamine primarily because it was found in an allium called garlic. So what they found about this particular form was that when you had allicin is it's a component of garlic. It's one of the things that gives it a very garlicky smell. It's very sulfury if you look at the molecule. Essentially, allicin, when you would break open garlic, what would happen is the small amount of thiamine that you do find in garlic, there's a chemical reaction which bonds that with allicin, and what you end up with is this compound which is kind of part thiamine, but also has many of the characteristics of allicin. It's like a thiamine with an extra special group on it. And what they found out was that this type of thiamine was superior across the board. Basically, what they found out was that you could get such high levels of thiamine inside the cells using this particular type of thiamine, and it was superior to every other form. So one thing that I haven't mentioned is about when you look at thiamine in food or synthetic thiamine like thiamine HCl, there's a problem with absorption. So absorption, you have these transport proteins in the gut, and that means that you can only absorb as a certain amount at any one given time, and it depends from person to person. What this means is you can only get so much into the body, and that's the kind of justification behind using intravenous thiamine, because when you saturate these transporters, the amount of thiamine, you can't absorb anymore, and so you end up just losing it in the stool. And this was a problem. So for someone who's severely deficient, you're limited in how much thiamine you can actually get into their cells, and therefore they can't get better, they can't improve. So this is something that the Japanese were very interested in trying to address. They identified this allethiamine molecule, and what they found was when thiamine was bound to this allicin molecule, it could bypass all of the different kind of natural entry points of thiamine, and that includes the intestine. So rather than going through an intestinal transporter, it could just basically melt through the membrane, diffuse through the membrane directly into the blood. And then likewise, not only do you have these transporters on the intestine, you also have them in the cells. So again, you can give someone intravenous thiamine, but you're still limited on how much thiamine can actually penetrate into the brain, for instance. There's the blood-brain barrier. Thiamine doesn't get into the brain very well. Thiamine doesn't get into the cells very well. You're limited in the amount that you can get in. And what they found was that using this allethiamine, it could bypass all of the known transport mechanisms. And so it essentially just melts through the intestinal membrane, goes through the blood, melts through the blood-brain barrier, increases levels in the brain, melts through the cell membrane, just gets directly in there and increases the amount of thiamine 10 to 100-fold, okay, depending on the dose. And so this was almost equivalent to using intravenous, but it was superior in many ways because it could basically bypass all of the rate-limiting transporters. And so they started using this type of allethiamine, and they found time and time again that this was superior on every single level to any other form of thiamine that they'd studied. So they'd studied sulbutamine, benfotiamine, which most people know about, and it's incorrectly assumed to be the better one. Yeah. They'd studied thiamine HCl, or, like 20 20, 30 different forms, and they identified that allithiamine was the most superior. And so from the 1960s, they had been using this in clinical practice, first in animal trials, then actually in patients. And they found that this was basically a very, very, very effective way at rapidly improving thiamine deficiency. What they did find was that, unfortunately, because it was bound to an allicin molecule, basically the smell, it would cause people to just exude this sulfury, garlicky smell. And so it actually reduced compliance. People wouldn't take it because they'd stink out an entire hall stinking of garlic. So what they did was they found a way to kind of modify the molecule and change it and get rid of some of the sulfur contained within it and produce kind of what is now referred to as TTFD. In Japan, it's referred to as phenylthiamine, but in the chemical molecule is thiamine tetrahydrofurfuryl disulfide. It's a thiamine bound with this extra TFD mercaptan group. And essentially what this form does is it provides all the benefits of allithiamine, but it does not have the smell associated with allithiamine. And so ever since the 60s, that's what, 60 years now, that has been the main form that all of the doctors and the entire conventional medical system uses in Japan. Now, unfortunately, the research is so scant on this. If you go into the Japanese literature, they have done lots of research on this, but in the West, it was never really adopted. Right? They've been using thiamine HCl or benfotiamine. They don't really know anything about TTFD. Now, this brings us to a well-known doctor, Dr. Lonsdale, who I spoke about initially when we started discussing this. Dr. Lonsdale, what he managed to do was he managed to import this. He was a pediatrician at the Cleveland Clinic. And so he was treating many children with dysautonomia and other kind of neurodevelopmental conditions. And what he managed to do was convince the FDA to import some of this stuff from China, because he'd been studying it, working with some of the doctors, from Japan, working with some of the doctors in Japan about with that. And so he started using this molecule, and he wrote and he documented hundreds or thousands of cases of the benefit of using this molecule. He's written many papers on this, and you just type in Derek Lonsdale on PubMed or ResearchGate, and you'll see all of the scientific kind of evidence that he's put together. And so he, like the Japanese, is convinced that this is the best form of thiamine because it has these abilities to basically bypass all those initial transport systems and really upregulate how the cells are using B1. Unfortunately, conventional and alternative medicine did not listen to Derek Lonsdale. They've not followed suit with Japan. And so they're using kind of suboptimal forms of thiamine. And don't get me wrong, benfotiamine it can be useful, but it's just simply not as effective as TTFD. And so that's one of the primary reasons why I became so interested in this molecule, and trying to use it in kind of clinical practice and seeing great benefits with it.
Yeah, I mean, I remember when I first started researching it, I was trying to look for different vendors. There were literally no suppliers in Australia. There was hardly anyone talking about it here. And so that's when I obviously I did more research, found a few companies overseas, and I think there were a couple of companies from the States. I think Cardiovascular Research may have had TTFD. But I want to give my listeners a chance to, if they want to purchase this, obviously this TTFD form, because that's the one I'm going to I'll end up doing some videos and talking about it myself, because I'm very passionate about novel compounds and things like that. So what I'll do for my listeners listening in, there's going to be a chance to order that particular form from your company. Is that right? So it's called Thiamax. Is that correct?
Yeah. Okay. So okay. Basically, right. I don't want to mention any names and discredit any companies, but there's only one company that falls under their branch of kind of two trade names. There's one company who makes it in the Western world, and they make a good product. I used it for a long period of time, and I still recommend it to some people if they can't access my product. Ultimately, it works as well. It's the same chemical, but as many of your listeners probably know, when people make supplements, when companies make supplements, oftentimes they add additives. So they add unnecessary fillers to make it cheaper to make the capsules, okay? And so, unfortunately, if you've got someone who's very sensitive to these capsules, then they can't tolerate these fillers. Magnesium stearate, for instance, silicon dioxide. I know that it's only some, but some people have kind of allergenic reactions or gut reactions to these fillers. And so my idea was to come up with a clean, pure brand of this, like a pure supplement, nothing else added. And so if we look at thiamine, kind of what it does, it's important to know that you need magnesium to use it. So thiamine and magnesium, they go hand in hand in most of the chemical reactions. And so what we did was we came up with a 100 milligram form of thiamine, no other ingredients other than a small amount of an amino acid chelate with magnesium called magnesium taurate. Taurine is very beneficial for the liver. Magnesium is useful for the kind of biochemical reactions with thiamine. But the majority of the capsule is simply TTFD. So my company is called Objective Nutrients. We're fairly new. We started around 6 months ago, and our product is called Thiamax. Now, we are going to be coming out with new products as well. So we're looking at kind of making lots of different products available containing TTFD that don't have any fillers. We'll be doing a complex in the near future. We're going to be I've just come up with a formula looking at kind of specifically designed for cognition. So it will contain TTFD, but also all of the other things that you need to generate acetylcholine, promote cerebral blood flow, all of this other kind of stuff. So what we're looking to do is really provide TTFD in as many forms as possible so that people can benefit from this. One thing that's important to note is that our Thiamax product, it is 100 milligrams, and that's a very high dose to start off with for someone. So what we generally recommend is that they open and they have half a quarter of a capsule, because if someone has been low in this for a very long time, they can have kind of what's initially referred to as a paradoxical reaction. That's how their cells are responding to this. It can cause kind of some unwanted symptoms temporarily. It can make some things kind of make their underlying symptoms worse for a short period of time. And so what we find is that actually by starting low and going slow and gradually building up to 100 milligrams, if someone's very deficient or very kind of has a long-term deficiency, then sometimes they can require anywhere from 200 to 300 to 400 milligrams per day. What we're also going to be doing is providing a pure powder form as well. So this means people can microdose or they can megadose. I've got some clients who personally I have on 1,000 to 2,000 milligrams per day. It's important to note that the RDA for thiamine is only between 1 and 1.5 milligrams. So that's up to 2,000 times the recommended daily allowance. But that is the difference. For some people, that's the difference of staying in bed all day and being able to function and work a job. So we're trying to provide as many options so that people can learn about and benefit from this molecule in as many ways as possible.
Yeah, I mean, once you release some of those other products, I'll definitely be looking into listing them on my website, because I know I'm very confident that they're going to be exceptional, and I'm looking forward to getting my hands on your Thiamax. So we'll definitely have to organize that after the show. But Elliot, I want to wrap up today's episode just by giving my listeners a chance to, I guess, see more of your content. So where can they learn more about you and some of your content as well? Okay.
So I have a YouTube channel. On that YouTube channel, I have various kind of lectures or videos or interviews with other channels and things where I discuss lots of different topics. I have kind of a wide variety of interests, but you'll find a lot of videos on thiamine, and I will continue doing that. You know, I have a passion on this subject. So you can find me at EO Nutrition on YouTube. I have a website, which is eonutrition.co.uk. On there, I occasionally write some articles. Sometimes I write articles for a website called Hormones Matter. And Hormones Matter is also a great source of information on B1. That is where you'll find the writings of Derek Lonsdale, or alternatively Chandler Mars. There's a lot of information on thiamine deficiency and the clinical application of thiamine. But as I said, I do put some information on there, and I also on my website. So on the website for Objective Nutrients, which is my supplement company as well, I write articles, some of them a little bit technical, but they are specifically geared toward educating people on TTFD, specifically the research behind this and how it has been used to address different kinds of health conditions, whether that be neurological health conditions, GI-related health conditions, or other things associated with that. And finally, I'm also on Facebook. So I do, I have a Facebook account, and sometimes I ramble on there a little bit or post studies and things like that. And I just made an Instagram account, but I'm not entirely sure how to use that, and I haven't really done much on there yet.
Awesome. Well, I'll be sure to link those for my listeners if they want to connect with you, follow you, subscribe on YouTube, things like that. I'll make sure that that's in the bio somewhere below. But Elliot, I just wanted to say a massive thank you for coming on the show. I knew this was going to be packed full of really useful information. I know I've definitely learned quite a lot, and I know my listeners will have gained so much value. So I just wanted to say a huge thanks for coming on the show.
Excellent. Yeah. Well, thanks for having me on, and it's a pleasure.
Awesome. Well, thanks everyone for listening in to yet another episode of the Boost Your Biology podcast.